strings to get you from here to here without crossing k. The highest they will go through is k minus 1. You all these guys, together with all the strings that will get you to k, right? Maybe do a loop around k, but eventually cross k and come to j. The strings that will not cross k plus 1 or higher are the strings that will not even cross k, together with the strings that will get to j by crossing k. That's true. Either you don't cross k, highest, right? Or you do cross k. So the highest, you look puzzled. To go from I to j without crossing k plus 1 or higher, right? How can I go there without crossing k plus 1 or higher? Either the highest I will cross is k minus 1, right? Or the highest I will cross is k. So I separate the two cases. So either you will not cross k, which means the highest is k minus 1, or you will cross k, which is the highest allowed. So now, how can I write this down as a recursive formula? Well, it will be all the strings that will take you from I to j, right? Without crossing what? Without crossing, not k minus 1, k. I said together with all the strings that will get there by crossing k. Well, together is union. Union, all the strings that will get you from I to k without crossing k. Without crossing k or higher.
K plus 1 or higher?
No, k plus 1 is here.
In the algorithm you said it's without going to any state labeled k plus 1 or higher. So it can cross through k.
Right, but I'm not done yet. So to cross through k, you have to get to k first. So all the strings that will get you to k, without crossing it yet, concatenated with all the strings that will wrap around k, maybe self-loops if you have any. Which means all the strings that will get you from k to k. I to k. Without crossing k star, k star, together with the strings that will get you from k to j without crossing it. Now you have to leave k and go to j. So concatenate with all the strings. Oops, we're outside the range here. Okay. This is our marker here for the camera. So you continue this here, concatenate from k to j without crossing k. That's the whole algorithm right here. Why? This is a recursive formula to cut in terms of the third coordinates. Why this formula gives us the algorithm? If you have an FSA and you want to find the language it describes, what is that it accepts? What's the language? Okay, let's take an example. I label the stage 1, 2, 3. Who is the final state? 2. I'm going to write down R, 1, 2, 4. What is that? R1 to 4, based on the definition, right? Well, R1 to 4 will be all the strings that will take you from where to where?
1 to 2 without going through 4.
Without going through 4 or higher. Well, there is nothing for, so they can go through anything they want. So if the third coordinate is the number of states plus 1, there is no restriction on the strings. So R1, 2 are all the strings that will get you to 2, which happens to be a final state. Is this equal to the language accepted by this automaton? Yeah, that's the language. What's the language accepted by this automaton? All the strings that will get you to the final state. Okay. What if I had 2 final states? Let's say this was also final. What is the language then?
R1, 3.
Union, all the strings that will get you to 2. Union what?
R.
What?
1 to 3.
Not 1 to 3. 1 to 3 means you want to go from 1 to 2 again. Huh?
You made it.
3 is the if 3 is the final state, then we have to find all the strings that take from 1 to 3.
Yeah, so what do I write here? Union, all the strings that what?
1, 3.
Not 1 to 2. What does 1 to 2 mean? Will get you from 1 to 2. If you write 2 again, I already got the strings that get you to 2. 1 what?
3, 3.
3? 3? Why 3? This means you cannot cross 3? Why you put the restriction? 4.
Okay.
Right? All the strings that will get you to 2, no restriction, together with all the strings that will get you to 3. The language accepted by the automaton is all the strings that will get you to either one of the final states. And in the deterministic automaton, the paths are unique. You know. So he will either get you a string to 2 or a 3 if he is accepted. What?
If we have one more final state, then we have to take union of the other final state.
Yeah. So right.
Then why?
So what's the language then? Why this formula is the whole algorithm? Because if you have an automaton, and let's say the final states are F1, Fn, right? Then the language of the automaton is equal to what? R, since we always label the starting state as 1, 1, Fi, F1, for each final state we have to do this. And here I have to put what? The number of states plus 1.
N plus 1.
Well, if n is the final state, you might have more. So let's say states plus 1. As many states as you have plus 1. And then you take the union for all the possible final states. So the language of the automaton will be the union of the strings that will get you from 1 to Fi. And they're allowed to cross anything they want. They can go around like crazy. Okay? So the third coordinate is states plus 1. Now, why I'm done? Because to calculate an individual states plus 1 coordinate, right, you can reduce it to states. The states must, if you had 10 states, right, for third coordinate 10, you can reduce it to 9, which can be reduced to 8, all the way to 1. And if the third, by using the recursion, and if the third coordinate is 1, for example, if I say, what is R1, 3, 1, or IJ1 in general. If the third coordinate is 1, what does that mean? All the strings that will get you from I to J without crossing anything labeled 1 or higher, this means they cannot cross anything. So here is I, here is J. So what is Rij1? I claim I know those. That's the stopping step of the recursion. For any possible I and j, Rij1 I know. Okay, what is Rij1? What are the strings that will get you from I to j without crossing anything? Well, it depends. If you have a link, labeled whatever, that's the string that will get you there. A. Rij1 is A. Right? If you have two links, maybe you go there for A, you go there for B. Okay? What is Rij1? Well, the strings that will get you from here to here without crossing anything are the direct links. So in this case, it will be A union B. It's either A or B. Those are the things that get you to J. So either if there is a link, it's the union of the labels, right? Or maybe there is no link. Well, if there is no link, what is Rij1? There's no way to go there. To go there, you have to go through another guy, which means you have to cross somebody else. So this one will be, in this case, what? The empty set. Unless I equals j, in which case it's E, the empty string. Okay, it's the empty set if I is different than j. The empty string if I equals j, and there is no link connecting them, right? So, for example, R okay, in this case, let's say here is node 3, and he does not.
You can have A to.
And he does not have a self loop. If he does not have a self loop, like things are coming in and coming out, but no self loop, what is R331?
Epsilon. Epsilon.
Right, epsilon, the empty string. How can you go from 3 to 3 with the empty string? You're already there, and you did not cross it. So this is either E, the empty string, or what if you had a self R? What is 331? A or empty string. Yeah. Empty string also does it. Okay? So in this case, this is A union empty string. So all I'm saying is, just by looking at the automaton, I know the Ij wants the case where the percode is 1. So this gives you an algorithm to calculate the language of an automaton, right? And express it as a regular expression. Let's do an example using this. Turn it off so we don't waste time. The tape is only 2 hours. Push the button. Okay. I want to find the language expressed as a regular expression. What's the first step? What should I do? Label the states. Okay, so I label the states. 1, 2, 3, 1, 3, 2, it doesn't matter how you label as long as this is 1. Okay. Then, for each final state, write it down. R1 final state plus 1. And take the union for each possible final state, because that's what the language is. All the strings that will take you, in this case, from 1 to 2, without crossing, as you said, 4 or higher. So you allow them to cross anything, that's the language. Okay, that's what I have to calculate. So use the recursion. What is this equal to? I remember it to do a small diagram. Where are you going? From 1 to 2. You're not allowed to cross 4 or higher. So what's the highest you can cross? 3. So put a 3 here. So what will this be equal to? All the guys that will get you there without crossing 3 are what? 2, 3. The recursion drops it down by 1. Union, now the concatenation. These guys, the self loops, these guys. So union what? R1 what? 3, 3. Concatenate with what? 3, 3, 3 star, because you can do it a number of times. Concatenate it with the strings that will leave 3 and go to 2. So you just what?
3, 2,
3, 2, 3. Okay. At any point, if I use to shorten it in a test, I can venture if I can tell what it is, you know. But it's a dangerous thing. I can make errors. Okay. The safest is to reduce it down to 1. Okay. Now you have to sit down. Each one of these you have to find. So substitute it. Let's find R1, 2, 3 down here.
You
Okay.
have to turn this on.
No, keep going. What is R1, 2, 3? What's the highest I can cross? 2.
2.
So it would be what?
A.
1, 2, 2. Again, this will drop down by 1. Union, what? 1 to 2 again. Two, 2, 2 star. And then 2 to 2 without crossing 2. R1, 2, 2. This means the strings that will get you from 1 to 2 without crossing 2 or higher. This means they cannot cross anything else. So to go from 1 to 2 without crossing even 2, how many strings do you see here? 8. So in a test, I could, you know, if I'm confident on my answer, I can put 8 here. Stop using recursion at any point. Okay? But let's use recursion. So now recursion, because the program you write, he cannot stop at any point and guess. Yeah, he has to go down to level 1. You can automate this. You can write a program to do this. So I have to figure out 1 to 2. Okay, this means to go from 1 to 2 without crossing 2 or higher. What's the highest you can cross? 1. So put it here. So what's 1 to 2? Going from 1 to 2 without crossing 1, this is reduced by 1 every time in recursion. Union, the guys that will get you from 1 to 1 without crossing it. Union, the loops around 1, R1, 1 star. I mean concatenation. Okay, concatenation, all these things that will take you 1 to 1. Now, your program can figure this out by looking at the adjacency matrix, the graph, the data structure used to represent this. Okay? 1 to 1. What is that? 1, 2 without crossing anything. As we said, if there is a link in the adjacency matrix, he looks at the entry 1, 2. There will be an A in there.
A or epsilon.
Not epsilon because 1 is different than 2. It'd be epsilon if you had I equals J. Right? In the diagonal, you will have epsilons in the adjacency matrix. Right? So here, when you start this graph, 1, 2, 3, 1, 2, 3. In 1, 2, you'll have an A. Okay. So this is an A. Union. 1, 1, 1. What is that? Epsilon, because there is no self-R. Concatenate. E star, which is E. Concatenate 1 to 1, which is A. A union A. The whole thing is A. So this guy is A. Figure this guy out. Right? So in the last step, he's looking at the adjacency matrix. He knows these things. Okay? So he got A. Okay, 1 to 2, I already calculated that's A. Now I have to figure out 2, 2, 2. Okay, what is 2 to 2?
B epsilon.
You go from 2 to 2, and the highest you can go is 1. I'm going to do the recursion to, I can look at it and figure it out, but I'll reduce it down to 1. 2 to 2, right? 2 to 2, 1. Union 2, 1, 1, to go from 2 to 1. One, 1, 1 star, 1, 2, 1. Okay, what is 2, 2, 1? B or epsilon? Union 2, 1, 1. From 2 to go to 1. Empty set. No string will do it for you, not even epsilon. You cannot go from 2 to 1 without crossing. Empty set. Concatenate. Now, once in this business here, in the concatenation, you got empty set, you don't need to know these guys. Because concatenate empty set with something else is an empty set. So the whole thing is the empty set. L1 concatenate L2 means all the strings you have formed by taking one in L1, one in L2. So how can you get an empty set L2? It's the empty set. So you have B union E union empty set. What's that?
B.
Union E. B union, why you forgot the E? E is a string. Okay. So this whole thing is B union E. So you have B union E star. So far 1, 2, 3 is A, union, A, then B union E star, followed by R to 2, which is B union E. So that's 1, 2, 3. So you just completed this portion of it. Okay, now you tell me.
1, 3, 2.
What do I put here to help me derive 2? So what's this equal to?
1, 3, 2.
1, 3, 2.
R 1, 3, 2. 1, 2, 2.
Right, 1, 2, 2.
2, 2, 2.
Star.
Again 2, 2, 2. 2,
2,
3, 2.
3, 2.
2, 3, 2.
Okay, let's take this one. 132. So the highest I'm allowed to go, I cannot go 2 or higher. Highest is 1. Okay, what's this?
Out of 131.
Wait, somebody else. Try to do this one. What is 132? What? I want to go from 1 to 3 without crossing 2 or higher. The highest I can cross is 1. So it will be the strings 131, right? 1 to 3 without crossing that 1. Union. 1 1. Not 1 1 3. 1 1. They will go from 1 to 1. 1, right? Without crossing that 1. Okay. And then star. And then okay, that's it. Okay, now these things will look from the adjacent matrix. 1 3 1. 1 3 1 is what?
B.